So in this video, I'm going to present to you the solution to number 52 of exercise 13.3. So we are given here of the curve r of t equals cosine of t, sine of t, L, and cosine of t, which is basically the same as the given curve in exercise 13.3 number 6. So here we're going to consider the point 1, 0, 0. So the solution here will be subdivided into several steps. So the first thing here is we're going to solve for the unit tangent vector at t equals 0. Again, the r prime of t is what we call the tangent vector. So this is going to be the derivative of the r of t. So we're going to have negative sine of t, cosine of t, and the negative tangent of t. And if we're going to get the magnitude of the tangent vector r prime of t, so we're going to have the secant of t. Now, if we are going to make use of these two, we're going to form here what we call the unit tangent vector. So we're going to have negative sine of t, cosine of t, negative tangent of t divided by secant of t. So eventually, we are going to have negative sine t, cosine of t, cosine squared t, and negative sine t. So, but then, if we are going to make use of double angle identities, so for example, if you're going to have the sine 2t, which is going to be 2 sine of t, cosine of t, so we can actually introduce here a 2 and divide it by 2, and eventually, you're going to have here the negative 1/2 sine 2t. Now, we also know that the cosine 2t is going to be 2 cosine squared of t minus 1. So you can manipulate this one so that we can get 1/2 cosine 2t plus 1. If we are now evaluating the unit tangent vector at t equals 0, so you will eventually get here the 0, 1, 0. For the next step, you're going to get here the unit normal vector n evaluated at 0. So using equation 10, take the derivative of the unit tangent to get negative cosine of 2t, negative sine of 2t, and the negative cosine t. Now, if you're going to get this one and take the magnitude, you will eventually get the square root of the square of all the components. You will have here square root of 1 plus cosine squared t. Dividing the t prime of t and the magnitude of t prime of t, you will get eventually the unit normal. So evaluating this at t equals 0, so you will have 1 over square root of 2 times the vector negative 1, 0, negative 1. And the last step here is to find for the binormal vector and evaluate this at t equals 0. So basically, we're using here the value of the t at 0 and the value of normal at t equals 0. So you're going to take the cross product. Eventually, you will get 1 over square root of 2 times the vector negative 1, 0, 1. So that's it. Thank you.